But in the past sessions, we have seen how to calculate VLP and IPR using the psapy correlation or library. And we also have seen how to import a well deviation service from Xml data. So what I wanted to do is using Volve data. What about bringing the real production, the real bottom hole pressure data, and calculating the bottom hole pressure using Bex and Brill or any other correlation and comparing? Okay, and it's not polished because few reasons. I may not be using the real the correct correlation. And there are a few other things that I need to have a look. But what I'm going to try is to use that library, the psapy, with Bex and Brill. We're going to try to bring the depth, the deviation survey of a well with the inclination. And for every date, we want to calculate the bottom hole pressure and compare to the bottom hole pressure that we have in the well at that particular date, and see if that matches or not. So if it doesn't match, it needs a bit more of work, but we'll see how it works. So I'm going to call this session or this exercise the bottom hole pressure calculation using psapy library with Volve well and production data. An actual BHP comparison. So let's see if that works. Okay, there we go. Sorry about that. So few things that we would like to do is I'm not going to go to the details, but on the last session I read the data from a Xml file. So I'm just going to reproduce more or less what I did last time, which is I was using a Beautiful Soup library to read the file, and I'm going to put the name of the Xml file here, the location. So that's the location of the Xml file in my drive, and I'm not going to go to the detail of all this code, but that's what we did last time. So reading the XML file, and I want to read the XML file for that well. Okay. Now if I go to the F, okay, that's a deviation survey for the well, and actually let me put the name of the well here. This is the well 9F15. Okay, there we have that well, and what we would like to do is using the psapy library. So if this is what I would like to do. I don't need this. I just need to import the Bex and Brill correlation from psapy as BB, and with that correlation and the deviation survey and some basic information about the well, I want to calculate the bottom hole pressure of a well. So let's put here some initial well info, and just to to be clear on this bit here, I'm not going to specify oil rate, water rate on GOR. These gas gravity, oil gravity, water gravity, they are not the ones from Volve. I have to work on those, and the diameter is not the one involved. I need to find that out. I'm not going to use the angle because I want to use a deviation angle from the survey here. And what I want to bring is the tubing head pressure. I'm going to use the actual tubing head pressure from the well. And I know that we have a bottom hole temperature and the tubing head temperature. I'm not going to use those. I'm going to use these for the time being for the exercise. And if I can calculate a temperature gradient for the well, very quick temperature gradient. Let's assume well, for the time being, let's give a dummy depth just to calculate the temperature gradient. Let's just return temperature gradient for the well. In fact, this is probably too much. Okay. Now, the data involved in the well deviation survey involved, it's in metric units, and the library that we're going to use, the psapy, is in field units. So I need to do some conversions at some point. But I know that the depths are in the data frame. I know that they are in the true vertical depth column. And I know that the temperatures, also I can calculate it better because I have the real time, the data from the well. For the time being, I'm going to say, well, my temperature, it's equal to the temperature gradient times depths. Okay. So now here I have my depths from the deviation survey, which again, these are in metric units, and then we have the temperatures along the wellbore. Again, these are field units. So I have to convert the temperature, the depths to, I have to convert the depths to fit at some point. Okay. Just trying to find where I did that bit of a conversion of the depths. Pretty sure that I did it before. Right. Yeah. So let's convert it to, yeah, should be fine. And also the other thing that I would like to bring, it's a inclination, which is equal to the data frame inclination. And I want to bring also the maximum TVD, which I think that I will use later on. In fact, that's fine. Oh, yeah, that's much better. Okay. Now, the way the library works, and again, this is something that we discuss in some other sessions, is I can calculate a pressure traverse for the well. I'm not going to go to the details, but this is, for instance, if I calculate it for a given oil rate, I can calculate the pressure traverse of that well, given some depths. So if I do this and I state Okay, and I want to calculate the pressure traverse for an oil rate of, let's say, 5,000 barrels per day. Oh, where is my THP? Okay, let's use a temporary THP here. I'm going to pass THP for the time being. 100 psi, and the water rate as well. Let's say that this is producing 500 barrels of water, and I need also GOR, which I'm not quite sure what was the value of a GOR, what was in the order of magnitude GOR. Let's say this is 300. I need an angle, which I'm going to set as 90. And this is angle. Okay, so what I have here, it's a pressure traverse of, if I show you what is pressure, that is a pressure along the wellbore for all the given depths of a well. So I can do a plt.plot of, it doesn't matter, but I'll do that in a bit. That's pressure and depths. Sorry, this is. It should be the other way around, but yeah, you can imagine. So that's, you can see how the pressure, it's increasing through as as the well gets deeper, and there is a bit of an effect of the inclination of the well here. Okay, so that's what we have at the moment. But we are interested really on the very last point of the pressure. So what we would like to get is a bottom hole pressure, assuming that this is the bottom hole pressure of a well, and I would like to compare this to the bottom hole pressure of a well from the database. So in fact, the bottom hole pressure from the Volve database, it's ohm bars. Okay, that's more or less the value. So here, now that we have the deviation survey and I have a way to calculate somehow the bottom hole pressure of a well, I'm going to now bring the production, the bottom hole pressure from the database, which is a bit of an exercise that we did before as well. Does this PSA library takes into account diameter changes due to various lower completions, Eulery's, etc.? Yes, you can, because the way this is working, it's you get the calculation of the pressure gradient along your wellbore. So this diameter can be an array of your how the diameter changes through your wellbore. Yeah. So tubing, anything that you have in the well, as you say, the Eulery. I'm assuming at the moment the diameter is fixed at 3.5 inches, but as I'm having an inclination and an angle that it's also in the data frame, I can also pass the diameter as an array. Yes, if that makes sense. So I'm going to bring the data from the bottom hole pressure from the database, and we know how this works. Again, we're going to bring it using these credentials. So we have the credentials that we set before, and don't need the meta. And And I'm going to use a query. And the query, I can use the same query that I used before. Let's see if I can use, where is that query? BHP from Volve session. Import data from, guess this is one, yeah. So I can use this function here, the custom function that I wrote before. And the only thing that we will need is now the information of what I would like to bring. So I would like to bring for this exercise, as I mentioned, I'm using the well F15. So I'm going to use a well F15, and I need to bring the dates and the bottom hole pressure for that well. So let's see if this works. Okay, there we have it, and I'm going to store it here in a data frame of production. And as you know, I can plot the, let's use scatter data for observed data. I can plot the F_plot dates, and I can use the F_plot, and then this is bottom hole pressure. The label, use the name of this well for the time. Oops, didn't like that one. X and Y must be of the same size. It's interesting. The F_plot dates and the F_plot bottom hole pressure. Oh, why do I have two dates? I don't think I need to specify dates here. Okay, there we go. So that is the observed bottom hole pressure. And what we would like to do, let's use this function that I wrote here above. We have oil rate, water rate, GOR, the angle, and the tubing head pressure, which we're going to set as a fixed tubing head pressure. But actually, yeah, that's a tubing head pressure. We can change the tubing head pressure to use the actual tubing head pressure for a particular date. And I want to calculate the bottom hole pressure for every one of those dates. I'm not quite sure if this is going to work as I intend to, but in fact, out of this, I don't want to return. I want to return, okay, pressure and DPD set. That's fine. Let's return those two values. So what I want to do is for every date I'm pretty sure there is some much effective way to do this with mapping and applying map functions and so on, but I'm going to do it like this for the time being. So for every date, I'm going to iterate on the data frame, and for every date, I'm going to calculate how much is my bottom hole pressure. And I need to do some conversions. I need to bring the oil. It has to be converted to the oil for every row. So that's what I'm going to do. I'm going to iterate on every item, on every date, of the data frame, and I'm going to bring oil volume, and I'm going to multiply that and bring it to field units by bringing it from cubic meters to barrels. So I'm going to do the same for the water. And I'm going to do the same for the gas. And I think the gas needs to be converted to cubic feet. So far, so good. And so I need to pass the first value. So out of all these values, I need to pass the first value in the array that is returned. Again, I think there is a much better way to do this using map apply in the data frame, but just this is what I figured out for the session at least. So now I have the oil, gas, and water, and let's define the GOR as gas over oil. And so what I want to do is do this calculation, the pressure traverse calculation. I want to do the pressure traverse calculation. I know that this will return P, and dP is set arrays. But what I really want to do is have an array of bottom-hole pressure calculated. And what I would like to do is append the bottom-hole pressure of a well, which is the last value in this array, if that makes sense. And I want to bring that in, if I want to compare to this, because the library it's in field units, I want to compare that to metric units. So I'm going to convert that to metric units like this. And this is going to fail, because I know it's going to fail. No, okay, not because oil ball, I didn't know that it was going to fail because oil ball was not found, but let's see. Right, so I need to bring not only BHP, but I need to bring also oil, Volve. I also need to bring water, Volve, and gas, volume. And I also need to bring the tubing head pressure, which I forgot to do before. Yeah, I need to do that. So that wouldn't change. And something that I didn't bring here, it's I need to do the same for the tubing head pressure, which is tubing head pressure is equal to that times this. And I think I need to multiply it by 14.5. Okay, hopefully this will work. Okay. Okay, oil rate is not defined. Oil rate, okay, I keep the, let's pass here oil, BHP, and this is water, and this is EOR, that's fine. Angle, and for angle I can pass, in fact, this function here, it takes a constant angle, but I can pass the inclination. If I would have passed here the inclination, and then I can use the angle for every section of the tubing. Yep, actually that makes more sense because there is an effect on the inclination of the well. So if I pass here the inclination, Still, okay. I'm having problems with the flow regime. That's fine, and which I know that those were going to fail. But I just want to make sure that if there is no oil production, this obviously it works for bottom hole flowing pressure. So if there is no well production, I'm just going to say that my BHP calculated for the time being, I'm just going to add 0 for the time being. On the contrary, if there is some production, I'm going to calculate the production, and I'm going to append it to a BHP calculator. And okay, sorry, equal 0. So it's something. So hopefully it's iterating through every date, and we should be able to do a plot. In fact, let me copy this plot here. And while this is doing some calculation there, and I'm going to plot for every date. The same here. I'm going to plot for every date. I'm going to plot the BHP calculated. And there we go, finished. Oh, okay. There we go. So it's obviously something wrong, which it would take me a bit of time to figure out, but I think I'm getting into the right direction where I'm having the observed pressure. I'm using the library already to calculate the bottom hole pressure. And I'm not quite there yet, but I think I need to fine tune a bit, as GQ mentioned, the diameter of the tubing, make sure that my units are okay. So once I have that, I think I should be able to adjust better this match. But as you can see, I'm getting into a point where I have the observed bottom hole pressure and I have my calculated bottom hole pressure. Okay. Yes, but I don't think that would be a big issue. The difference is quite big to justify that the gauge is not at the depth. But yeah, certainly I'll have a look at that. That is a good point. So I guess that's it for today. I would like to finish a session with asking for suggestions, comments, or questions on the previous exercises. This one, or what is it that you would like to see? Where do you see potential? Well, the friction losses are calculated in the Beck-Breel correlation. That's inside the correlation. Okay. Yeah, maybe. I don't know if there are some defaults that are there assumed, but those are inside the correlations. Whether there's the question if it's probably the pipe roughness. Yeah, I have to think about that. If it's I don't think I have overwritten. It's nothing related to a roughness there. Yeah, I need to change some of the defaults. As I mentioned, the oil gravity is not the one from Volve. I need to change this. I need to change the gas gravity. Water gravity wouldn't make a problem. But tubing head temperature, bottom hole temperature, I don't think that will be an issue. But yeah, you get the point. We've got it up to a point where I can pretty much. I'm pretty much very close to fine-tuning this, and if I have some real-time data every day, I can probably compare to my my real-time data and compare IPR and compare the bottom hole pressure to the calculated ones to the real-time data every day. Yeah, yes, Leopoldo, good point. Jacob says that it's a good session. The only thing I feel takes time for industry professionals to change from commercial software to open source. And other issues that federal governments doesn't believe your results unless it's coming from Eclipse or Prospect. Yeah, that's fine. Absolutely fine. But I think, yeah, from the point of view of using these libraries, you also have to be very careful. Yeah, we are not saying that. I mean, Eclipse, as you mentioned, and some of these other tools I have been in the market for ages. So you probably, if you're using this, you need to make sure that whenever you're using it, you're validating with some of those tools and making sure that what you get back, makes technical sense. Having said that, open source, the only industry that it's really lagging behind in open source adoption is oil and gas, and that's why digital transformation is so behind, or one of the reasons why it's so behind in oil and gas, apart from data collaboration and yeah, and yeah, and most of the softwares are pretty isolated in terms of how much they can you can take information out or in from these applications. Yes, linear regression suggestions of linear regressions of correlated data, working with Spotfire and embedded Python. Thanks. Yes, Spotfire, it's proprietary, commercial. I don't think that we will see any session on Spotfire on those. I think we're trying to make it at least open source, free. Well, I don't know, probably open Spotfire. If I manage to get a license again from Spotfire, I can show a few things, and I can show some of the Python integration, and our integration is in Spotfire. Linear and non-linear, we are thinking that in the future. We did some linear in the past with simulation results, but I think we will at some point start to do some scikit-learn sessions where we will go from linear, logistic regression, and so on, and we move up into the ensemble methods and machine learning, decision trees, and so on. MVA for shell. What do you mean MVA? Jico suggests MVA. Oh, multivariate analysis. Yeah, yes. So if you have a data set and you want to do that, perhaps we can work on that. But yeah, multivariate regressions might be something that we could do. I'm not quite sure what I need to understand what you mean with shell data set. If you're talking about shell like production data and so on, yeah, we can do some of that at some point. Okay. Yes, exactly. Yeah. Yeah, got it. Anything else before we leave? Well, thank you everyone, and I hope that the session was useful for those connected. Okay. Thank you. Take care all.